All right, hello everyone and welcome to Arduino Day 2021, brought to you by the Education Makers, a research group that promotes learning through making. Today you'll hear from makers via presentations and demos of Arduino projects to celebrate this exciting world of open source hardware and software projects and the user community that designs and manufactures these single board kits for building digital devices. This event is organized in collaboration with the Milieu Institute, the Innovation Lab, Dawson College, and Virtual Force Space. Nous aimerions commencer par reconnaître que l'Université Concordia est située en territoire autochtone, lequel n'a jamais été cédé. Nous reconnaissons que la nation Kanien'kehá:ka comme gardienne des terres et des eaux sur lesquelles nous nous réunissons aujourd'hui. Tiohtià:ke, Montréal, est historiquement connu comme un lien de rassemblement pour de nombreuses Premières Nations et aujourd'hui une population autochtone diversifiée ainsi que d'autres peuples y résident. C'est dans le respect des liens avec le passé, le présent et l'avenir que nous reconnaissons les relations continues entre les peuples autochtones et autres personnes de la communauté montréalaise. For those of you unfamiliar with us, Concordia University's Force Space is a university-wide platform focused on working collaboratively with our community across disciplines to activate research, teaching, and various initiatives via interactive events such as this one. So we're super happy to have been invited to participate. We are currently recording this session and live streaming at CU Force Space on Facebook, so I'll pop those links in the chat in a minute. You're more than welcome to join in the conversation today. There will be a Q&A period. After each demo or presentation, we've opened up the chat for you to be able to write any kind of comments and I guess virtual applause, if you will. But if you do have questions for our presenters today, we ask that you participate in one of two ways, either by popping your question into the Q&A box if you're more of a texter and our moderator will be sure to address it, or if you prefer, just lift your virtual hand and we'll sweep in and unmute you and allow you to speak. Okay, on that note, it's my pleasure to pass the floor over to Concordia University Research Chair in Maker Culture and Louise Davidson. Over to you.
Thank you, Anna. Bonjour à tous et à toutes. Je vous souhaite la plus chaleureuse bienvenue à la Journée internationale Arduino. C'est un événement open source qui est très important pour Montréal et pour l'Université Concordia, puisque pour nous, notre communauté, c'est notre plus grande richesse. Hello, everyone. I wish you the warmest welcome to Arduino Day 2021. This event is a worldwide celebration of the open source community and the achievement of its members. Today, there are over 300 events happening in 70 countries. This year, Arduino is titled Undistancing Open Makes Us Closer. More than ever, we need to leverage open source technologies to unite humanity because we have the power to shorten physical distance by creating opportunities to collaborate, to innovate, and to bring people together online so we can explore new ideas and find solutions to real problems using technologies. Over the years, we have maintained a very close relationship with Arduino, and we have a very special message for you directly from Arduino Education. So I will share my screen so you can hear the wonderful message sent to us by Roxana and Melissa.
Hello, everyone. Here, Melissa and Roxana from Arduino Education team. I'm from EduVision.
Hey, nice to meet you all through this video call.
So hello to all the education makers in Montreal.
Yes, we heard that you're also celebrating Arduino Day today. So nice to hear. And we would also like to see what are the projects you're building, maybe today or before you have them maybe ready for this day. So please share them.
Yeah, we want to know what you are making.
Definitely. Yeah, you can share them in social media using the Arduino Day hashtag, or even if you have some ideas for what we should have in our next season. I don't know if you know, but EduVision Season 3 is starting soon. You can write in for example, if you're watching the old episodes in YouTube, you can comment there, whatever works for you.
Yeah. So thank you so much and have a great Arduino Day and keep making, sharing, and inspiring cool things.
Bye.
Thank you. Bye.
Okay, and over the past years, actually, we had several education makers who did show up to Arduino Eduvision. Ivan Roby with his crew last year was featured in an episode, and also Natalie Duponcel was actually featured. So don't hesitate and reach out to us and to them so that you can present your projects. So today we have the wonderful honor of having Nadia Bouyan, who is an engineer, a woman in STEM, also our Vice Provost of Partnership and Experiential Learning at Concordia, who will give the opening to the event as well. Over to you, Nadia.
Merci beaucoup, Anne-Louise. Good morning, everyone. Bonjour tout le monde. Great to be here with you on this very early Saturday morning for some of us. So, you know, what can I say about learning through making? I'm a firm believer in hands-on learning. I better be, because it's part of my job anyway. But as an engineer, I really believe that to understand how things really work, you need to tinker, you need to get your hands dirty. And for me, it's really one of the best ways to learn. There's so many cool and amazing things that can be done with the open source platform. And open source is all about access and empowerment and participation of all people. So regardless of your background or where you are in the world, you can create, you can contribute to open source communities. And open source has democratized technologies like Arduino, and it helps to put powerful tools in the hands of anybody who wants to try something new in a hands-on way. And these are the learning experiences that we think are really important as we're in the throes of the fourth industrial revolution. These are also the types of learning experiences that we want our students to have at Concordia's Innovation Lab, which is going to officially be launched next week, but it has been active since January. And in the lab, our students are designing and prototyping ideas for real end users and developing their innovation skills in the process. And a couple of these students are going to be presenting here today. So on that note, I'd like to wish you all a happy Arduino Day and keep on making. So back to you, Anne-Louise.
Thank you, Nadia. C'est la brillante et lumineuse Rima qui va animer les présentations. She's probably one of my favorite makers who in the past has created a portal gun, which has transported her to all sorts of places, metaphorically and physically. Over to you, Rima, to present our list of presenters, and I will mute myself from now on until the end.
Thank you, Anne-Louise, for the kind introduction. I sure miss our days in the makerspace. We have a very exciting program for today. We have very interesting people from Concordia University doing their masters and PhDs, from U Laval, just like myself, Florida State University, students from Collège Saint-Sacrement in Terrebonne, and Dawson College. So let's start with embedded wearables. Our first presenter is Huda Jauhar, who is doing her master's in educational technology at Concordia University, and who is going to talk about her electro-knitting project. So Huda, you can go.
Thank you, Rima. I'm just going to share my screen. Okay, so hello everyone. Thank you, Rima, for the introduction. As Rima mentioned, my name is Huda, and I'm a master's student in the educational technology program at Concordia. And I'm currently in the process of graduating, and at the same time, I'm working as an instructional designer at District 3. So I started my journey at Make over now almost 2 years ago with the pandemic by attending different workshops, including basic electronics, 3D modeling and printing, Arduino programming, and robotics. And all of those workshops were the main building blocks that led me to the project Fabric of Make. This project was inspired by the work of Joyce Wieland, merging her exploration of various materials in her artwork and her attempt to reclaim needlework as an art that requires high levels of skills and inventiveness. And this opposes the traditional devalued perception of quilting being women's domestic work or craft work. What I'm going to be presenting to you today is one of the most challenging pieces, but also one of the most fun of them all, which is the electro-knitting piece. It's a fully knitted breadboard. As you can see in the pictures, it's a fully knitted breadboard with NeoPixels soldered on it in series, and the NeoPixels react to sound that is picked up by a microphone. So now I'm going to stop sharing my screen and tilt my camera to show you the piece in action. Can you see it? Yes. So the idea of a knitted breadboard began as I was trying to understand how a breadboard works. And the way that the rows are connected made me think of it as a knitting pattern. From there, I started drafting knitting patterns and circuit diagrams and prototyping them. I used cotton yarn and copper wick. And the way that I got to copper wick, I was thinking, okay, I need something that is pliable enough so that it can be knitted and at the same time be used as a conductive thread. So I used the copper wick, and across the piece, there are two lines that connect to the power and the ground. And then we have the microcontroller, and the NeoPixels are soldered directly in series and connected to the microcontroller through a data line. Now, all of those beads are used for insulation, and it's kind of an added aesthetic to the piece. And what's being picked up, and the lights are lighting up now, they're reacting to my sound as I'm talking. So the microphone is picking up the analog signal, which gets transformed into a data signal through the microcontroller, and then lights up the lights according to the intensity of the sound and the volume. And that's it. It's super fun to watch it while playing music. To be honest with you, I sometimes use it as a form of meditation. And what this piece has allowed me to do, it has allowed us really to explore things at this intersection of different concepts, different materials, where we combined basic electronics, programming, and knitting. Explored different materials to test their conductivity, what works, what doesn't work. There was a lot of iterations even in the design itself until it ended up being the final piece. So thank you, Rima, and back to you.
Thank you, Huda. Next, we have Rita Kesselring, currently doing her master's in fibers and materials practices at Concordia University, and who is going to talk about analyzing the humidity factor to expand face mask research.
Yeah, thank you. So I will start with sharing my screen as well. So there you go. So I'm actually really happy to be here today. I'm part of a bigger project, so it's not just me working on that. I'm part of a MyTax grant that Concordia University received in collaboration with the ERSST Filtration Aerosol Laboratory, which is at the down in the basement at Concordia University. And so we are actually looking at different ways to improve face masks and find maybe an alternative to polypropylene face masks. So I personally was working on to try to find a way to understand how come a cotton face mask is not that comfortable for someone who is working the whole day, physically working, I mean. And so talking with my partner who is here on this picture, he said, well, the problem is that after 45 minutes, I have really problems to breathe through that cotton mask that you made for me. So that was kind of the beginning of my investment. So I was looking at, well, what could happen? And he said, well, it is becoming like really wet. Could that be a problem? And so what I did was creating a circuitry and a wearable with a humidity sensor that is actually analyzing what is happening inside the mask. And coming from a textile background, I could imagine that actually when you wet a fiber, it gets like thicker. So that must have an impact. So the Arduino project, so here I use a little Arduino Mini and an SD card reader. I put here a little slide. So I started with this basic diagram found online, so open source. And then I just changed a little bit the code to really get the data I wanted to have. And I designed my own face masks that are really tight, because one of the big problems is that the fitting, most of the times the fitting is not good, so the face mask is not efficient. So I designed this mask. I tried out different materials, cotton, linen, silk, and polypropylene masks as well. And for each of them, I created like this little pocket you can see here, to actually put the humidity sensor inside of this pocket made out of the same material and then put it inside the mask. I added this because if you have the humidity sensor right on your skin inside the mask, then for sure it will just show like at each time you breathe, it will just show like 99% of humidity, right? So that didn't make any sense. And so here are different prototypes. So I tested out many different things. And here are some of the data. So I take the raw data and then put it into an Excel file and make diagrams out of them to analyze. When you see those gaps here, sometimes it's because he was having a coffee, so he took a break. Or sometimes also it's because it is moving. But what we can see from the first analyzings of this is that actually here is cotton. Cotton is getting like super densely humidity, like the humidity is getting like really high, and then some silks are better, and then the light silk that I'm using right now, the humidity is quite equal to the polypropylene, so which is interesting. So the next step will be to put that into to reproduce the same data that we have in the laboratory. So the project is actually not finished yet. So this here is the wearable, but I will stop sharing and show you the real thing. So it is here. So this one is made like really tight to fit on the body because he's working physically and around big machines. So the problem was that it couldn't be loose, otherwise it was dangerous. And I'm having here a second one, which will be available at Concordia soon for people to try out. So what I actually do when I embed electronics into wearables, I always make sure that like it is flexible. So here I used some conductive thread to have like here at the bottom are my electronics, which are at the lower back of the, lower back, because it is like not disturbing at this place. But then I need to have like the collection of my data up on the shoulders, where is my humidity sensor. So to make that way in between, it is all sewn with conductive silver thread. And yes, I don't know if I have something else. I don't know. No, I think that's it for now. And so the project is not finished yet. There is still a lot of analyzing to do. But so Arduino is really helpful to collect data and maybe improve face masks. Thank you.
Thank you, Rita. Next up, we have our presenters from Collège Saint-Sacrement, starting with Ludovic Bouchard, who is going to present his automated greenhouse.
Ouais, donc moi je vais présenter en français, mais j'ai la diapositive en français et en anglais. Donc petite diapositive pour vous. Une serre automatisée. En fait, je l'ai programmée moi et mon ami, mais c'est un projet de secondaire 5 à l'école. Donc, le but en fait c'était de faire une serre automatisée qui pouvait être 100% autonome et pouvant être contrôlée et monitorée à distance. Donc on puisse voir certaines statistiques, des graphiques sur qu'est-ce qui se passe vraiment dans la serre. On s'est fait un algorithme assez simple. Alors on commence. Alors, donc ça, on utilise 3 Arduino qui contrôlent chacun la lumière, la ventilation et l'eau pour arroser les plantes. Donc au début, en fait, on a un affichage qui nous dit combien de temps avant admettons, arrêter d'arroser ou combien de temps avant de commencer à arroser. Puis là, on a une minuterie pour les lumières. Donc, un circuit, c'est assez simple. On a un Arduino avec un LCD Shield. Ensuite, on aurait qui est connecté à un relay. On a la source qui power la lumière, la pompe ou la ventilation. On en utilise 3 pour les 3 parties. Donc, on a quelques photos du projet en question. La photo du milieu est pas à jour parce qu'il manque le 3e Arduino pour la ventilation avec le relay. Mais à droite, vous pouvez voir à quoi ça ressemble un module. Le code est assez simple. En fait, on fait un setup. Ensuite, on calcule combien de temps il reste. On affiche le temps qui reste. Puis ici, on doit activer ou désactiver, donc le temps est égal à 0. La minuterie est arrêtée, alors on recommence la minuterie, puis on active ou désactive la pompe, la lumière ou la ventilation. Donc, comment est-ce qu'on va faire pour que ce soit contrôlé à distance puis qu'on puisse monitorer la chose? On va utiliser un Arduino au plat IoT Kit. En fait, c'est un Arduino Wi-Fi qui est connecté à ce board-là, avec des boutons tactiles et un écran. Ça peut être utilisé avec, en haut à droite, on peut voir l'affichage que ça nous donne en fait. On peut le programmer avec plein de variables. Ça a aussi un moisture sensor, donc pour automatiser l'arrosage des plantes lorsqu'ils sont rendus sèches dans la terre. C'est tout. Merci. Merci pour l'écoute.
Merci, Ludovic. So our next presenters are Thomas Prescott and Colin Gilbert, here to tell us about their smart car project.
Yeah. So share my screen. So first of all, hi to everyone. Today, me and my friend Prescott will present to you our project, Arduino project, and MBOT Ranger. So we're in secondary 5 in Collège Saint-Clément, and it's our first year in coding in Arduino project. So first of all, the goal of this robot was to follow a line, simply, but after all, it's looked too easy for us, so we will to make it more spicy. So we had another goal. It was to counter an obstacle, and first of all, for us, it was like too impossible because we're beginner. So we try and we try it and we get it. So now let's Prescott tell about the flowchart and the program.
Yeah, so I'll start off with the flowcharts. We recently just learned how to draw a flowchart, which is the planning of a project. So right off the bat, we just got into it and wrote a very complicated flowchart. And I think flowcharts should be very simple. So we quickly realized that it was not suitable for our level of skills. So what we did, we started off from scratch, and we did a flowchart very much simpler than the first one. This was kind of the only planning we had for the project, and I feel it's important to present this because no project will be made if there is no planning. For the Arduino part, we used the Arduino Uno card on the MBOT Ranger, which was already pre-built. So unfortunately, we haven't had the chance to build ourselves the robot, but I think it's still a good project, even though we can't build. For the coding, we use a block on MakeBlock, the software, where it allows, the software allows to connect a lot of devices, which Arduino takes part of these devices. And when we coded, we start off like everyone with just go in the coding without even following the plan to see how the robot reacts. So we had a lot of hard times to play with just playing with the robot and everything and trying to tweak all the little details. And we finally realized that it was all a mess and we needed to restart from the beginning. So we restarted from the beginning and we followed our simple flowchart that I previously talked about. From there on, we just wrote it down just like we have planning, just like the planning was supposed to be. And then after all that, we just made little modification to perfect the code so that the robot could go around a loop by itself and try to avoid an obstacle so it doesn't, let's say, go in the obstacle. Now we saw that Arduino had a lot more potential than do a robot like this. Like I just saw you guys' projects before and it was amazing. But in the process, we realized that there's a lot more to Arduino than just going around the loop. So I'll let Colin talk for what we learned.
Yeah, so in this project, we learned a lot of things. But first was like the organization, because what you say already, by the first time we tried to code the robot, we didn't have a plan or a flowchart, and the code was like doing no sense. So we failed. So we try again, and with a plan and a flowchart, and we follow the plan for the code, and it's really worked well. So this is something we learned to do a flowchart. And the second thing is to make it simple. Make a simple code first, and after add another simple code, and to make a more complex project. And this is what we do in our project. At first, we do one code that is simple, like to follow a line. And after we add another one to avoid an obstacle. And at the end, we're really happy that it's worked and it's a cool project. So finally, in the what we're gonna do in the future with the Arduino. First, we wanna learn the Python code, because I think it's a really cool language to learn for Arduino coding, and explore the Arduino world, because we just do a small robot, but I think there is such better things we can do with Arduino. So yes, I think it's two for me.
Yes, we want to explore more of Arduino and how it does work. This was one project in school, like Ludovic had the other one. There's two more, so till the end of the school year, we want to see if we can do anything else with Arduino and seek for inspiration of you guys. So thank you all for listening, and thank you.
Thank you, Thomas and Colin. I remember going through the same process when I did my project. I wanted to go straight to the hard stuff, and it messed up everything. So I had to really take it step by step and plan everything. So I totally understand where you're coming from. Now we will move on to the students from the Innovation Lab. First is Geneviève Lamarche presenting her Lego Star Wars Christmas wreath.
Yes, good morning, everybody. I'm going to share my screen like everybody else. Where is it? Okay. So this is my first project, to be fair. I'm a maker who decided to go back to school last year in university in education. And I luckily met Anne-Louise Davidson, who brought me on board to the Innovations Lab and in the Makerspace Challenge. This is actually my very, very first Arduino project. To be very honest, I was always, how can I say, intimidated by Arduino. No problem building a 3D printer, but when it came to Arduino, I was scared. So I started very, very simple. I started with a simple LED project. And because I was slightly intimidated, well, I got a lot of help from a person named Ivan Ruby, who's actually here today. I did one of his online classes, and the way that he directed his class was so easy. It made me feel very comfortable with the technology, and it helped me get my project up and running. So what I did is, well, I did a Christmas wreath. I got very inspired by Star Wars. They got a project online, so I copied it. I had everything at home. So what I decided to do, I decided to add a bit of X-Wings coming out of space with stars. That's it, simple. However simple as it wasn't that simple. The first thing I did, I planned. I did everything on paper. I wrote my whole plan on paper just to see exactly where I was going and what type of things I actually needed to build it. The next thing I did, I followed Ivan. I went online. I went to Tinkercad, and I plugged everything virtually. And then I did the programmation of, again, simple, turning lights off and on. It worked online. I corrected my code because every time you had an error, Tinkercad actually gave you the troubleshooting. So I read my troubleshooting and I corrected as I went. The moment I got it up and my code, as you can see, I did soldering very quick and dirty. I got it up and running. And as you can see here, it's right there. What's interesting about this project is now that I got one aspect completed, my personal, how can I say, self-confidence kind of said, oh, what else could I do with this? And that's what was the interesting part of the Arduino, is the fact that you get one thing done and then your brain starts going. It's like, okay, what else could I do? What else could I do? A lot. I ordered mini Arduino speakers. I've got sensors. So now what I'm going to do is, of course, I'm going to do a movement sensor. So the moment somebody moves in front of my Christmas wreath, of course, Star Wars music will be playing. I'm waiting, yeah. I'm waiting for the equipment coming from Amazon, but the moment I get that done, all the equipment, I'll be putting music to my my Christmas wreath. So that was my first project. I want to say thank you to Ivan Ruby, who really helped me get this up and running. So yeah, thank you very much.
Thank you, Genevieve. What a creative project and a very good Christmas decoration. Next, we have Melise Ferrous, who is going to talk about bringing makerspaces to life.
Perfect. Thank you. Great. So let me just share my screen. Cool. Can everybody see what I'm sharing? Yep, I see fingers. Cool. So hello, my name is Melise. I'm here to present, technically, I guess, on the behalf of our group, of which Genevieve is also part of, but I'm just going to let you know a little bit about the democratization of education. Cool. So here's what I'm going to be going over. So first part to going ahead and starting up something is coming and running. You would never go into making a puzzle without knowing what you're making. You never make a building without just having some form of blueprint. So then why do we come into 3D printing and makerspaces absolutely confused? Well, that's not really something that we need to do anymore. You know, when you might walk into a makerspace for the first time, it might look quite intimidating, especially when you're coming into something like this and, you know, you're, you know, never really had experience with any form of technology. So how do you get started when you're walking into a space that's looking that insane? Well, let me give you a little example. So here's a project I had done for a class. I was just doing a project on the precession of equinoxes. Well, I don't have access to anything, any crazy technology at home, and I'm a poor student. So how am I going ahead and making this? Well, not by listening to Bollywood music. Oopsies. I exited full screen. 1 second. Oh, are we just going to stay here? Yeah, okay. Sorry about that. Cool. Great. So the secret was here all along. It was open source. The thing I just showed right now was me using Blender. Blender is an open source technology. If I can go ahead and have access to animation by using Blender, then you can have access to basically anything. Here's an example. So one of my competitors against Space Concordia is the Portland State Aerospace Society. Though it's probably to the detriment of themselves for the competition, it ends up making the world a better place. They have all of their blueprints, all of their hardware, all of their software available online for anyone to go ahead and follow along with the rocket process that they're doing. So let's say you're not an engineer. Great, neither am I. We can also go ahead and use democratization and open source technologies for things like animation. For myself, quite often when I'm going ahead and making sceneries for video games, I use Texture Haven, which allows me to have open source access to technology to make sure that my scenery is looking realistic. I save a lot of time and it makes me not get frustrated with the whole process, thus allowing me to learn more than sitting there and just playing with textures all day. And eventually we will live in a world where we no longer need Anne Louise. Okay. We'll live in a world in which we can go ahead and just look up most of our things. And we already are living in this type of society now. So if you ever get discouraged and you're not sure where to get started, but you know that you want to get started, just know that there are open source technologies available for you. So let me tell you just a little bit about our own project. So design thinking, what is it? Well, what we've been learning quite a bit is about the design learning phase: empathize, define, ideate, prototype, and test. Why are none of these connected? Because it's never a steady process. If you go ahead and go and ideate, you could realize, hey, I need to go back to define. You might even need to go back to empathize. So let's not even make arrows, because just know that you're just going to have to hit all of these boxes and you never know in which order you're going to be going. So just a little bit about what we're currently working on and why we went ahead and want to make democratization of technology a lot more familiar to people under the age of 25 or people in university, because quite often right now we live in a world in which we're going ahead and adding in these maker spaces, and we have exactly that. You come into a space, you have no plan, and especially when you're under the age of 18, there's nothing to really encourage you to continue with what you're doing. So we want to make sure that we're giving both the access to technology that students need, while also giving them expert, so that they can learn how to be independent, while also giving them some form of background so that they don't need to be entirely independent, because that's for people that pay taxes. And if anybody has any questions for me, you can feel free to pop it in the chat. And thank you for your time.
Thank you, Melise. Our next topic is robotics and teaching of STEM sciences, starting with Demetrius Rice doing his doctorate in instructional systems and learning technologies at Florida State University, here to present his articulated arms project.
Hello, thank you for having me. My name is Demetrius Rice, and I'm a doctoral candidate here at the Florida State University, located in Tallahassee, Florida. And prior to my graduate studies, I spent about 10 years in the K-12 space, and my focus has mainly been electronics at the component level and robotics. And now even as a graduate student, I work with other teachers around our district and around the state as far as implementing robotics in the classroom. And I have to be able to use all the different platforms, Lego Mindstorms, Vex, Arduino, etc. And so what I have here is an example of probably what students will be working on maybe in their senior year, kind of as a capstone project, depending on where they kind of entered the robotics progression. And what we did here with this particular robot is we started with the chassis first and to get this rolling. And then the next thing we built was the articulated arm, and then we mounted them together. So what I'm using here are the structural and electronic components from Vex. And just to give an example, is that I have 4 motors, one for each of the wheels here. And then for the 6 articulation points, I have 1 motor controlling the base. And then I have 2 motors that's controlling this point because of the weight of the arm. Then I have another pair of motors that's controlling this section of the arm. And then for the 3rd articulation point, I have 1 motor. And then for the 4th articulation point, another motor. Excuse me. And then I have my 6th articulation point here. So all in total, I have 9 motors on the arm, and I also have 4 motors controlling the base. So the problem that I have is this proprietary processor by Vex only has 12 motor ports. So as a solution to the problem, in order to be able to control the 13th motor here, we're using an Arduino Uno. And so I have mounted on top of it is a motor shield. And so what I've done, it's still in the prototype stage at this point. So what I have here is a push button that allows me to open the claw, and then a push button that will close the claw. You can see here that I have a breadboard here, and I have I'm using a 9-volt battery to power the Arduino. so that way I can still move it around. But the next step in this process of what I want to be able to do is to have the Arduino and this processor here communicate with each other. So that way I can just use the remote control to be able to open and close the claw instead of having to manually open and close the claw using this. So hopefully by next time, if I'm fortunate to participate again, that this will be cleaned up and solved. And then I believe as Genevieve said, once you get started with one part, like, you know, we're already thinking of some extra sensors and some different things that we want to add on to it because of the open source and then just the versatility of an Arduino board. But that is my project, and thank you for having me.
Thank you, Dimitris. Our next presenter is Christian Collin from Université Laval, here to talk to us about secondary 4 students with Arduino.
Bonjour, je vais vous partager mon écran. La présentation sera bien sûr en français. Alors, je vais vous présenter ce matin le travail que je fais avec mes élèves depuis une dizaine d'années par rapport à l'introduction à la robotique au niveau du 4e secondaire quand on étudie le volet de génie électrique. Moi, je vais vous présenter en réalité aujourd'hui les fondements du projet. Donc, vous allez voir un projet en particulier, le projet de jeu questionnaire, un peu comme le génie en herbe, où les élèves peuvent peser sur le bouton pour donner une réponse en allumant une lumière et après ça, avoir un bouton de reset pour repartir à zéro. Donc, le projet, en réalité, fait 10 ans, je le fais. Je le fais de différentes manières. Donc, là, l'exemple que vous avez là, c'est un exemple d'une année en particulier. Donc, c'est pour répondre justement au volet génie électrique et en même temps d'allier la construction d'un objet technique et la programmation. Et surtout, là où j'essaie de pousser un peu plus les élèves, c'est au niveau de l'algorithme. Donc, vous voyez le processus, on a l'analyse du problème, la création du cahier de charge, mais ensuite, l'algorithme prend beaucoup de place parce que c'est là que l'élève va devoir dire comment il va procéder, analyser vraiment chacune des étapes. Par exemple, pour le jeu de génie en herbe, de décider, quand quelqu'un pèse sur un bouton, automatiquement, ça veut dire que les autres ne peuvent plus peser sur le bouton. Donc, c'est toutes ces choses-là qu'ils vont devoir analyser. En même temps, c'est sûr que l'algorithme, oui, on a un avantage à l'utiliser en programmation, mais par la suite, les élèves, quand ils viennent pour faire de la résolution de problèmes, résoudre d'autres problèmes en sciences, résoudre d'autres problèmes en mathématiques ou d'autres matières, à ce moment-là, ça va les aider aussi à progresser. Donc, à ce moment-là, on augmente leur capacité justement à résoudre des problèmes, peu importe la matière. Ensuite, il va y avoir la construction du prototype. Je vais vous montrer ici. L'algorithmique, vous voyez, c'est un algorithme justement un peu fait au propre de la part d'un de mes élèves pour justement le jeu de génie en herbe. Et on voit justement tous les processus qu'il y avait à penser pour faire en sorte que le jeu puisse fonctionner. Par la suite, la partie, j'ai beaucoup d'élèves qui vont aimer plus cette partie-là où ils vont devoir aller construire l'objet en tant que tel. Donc, on va aller dans notre bon vieil atelier pour fabriquer l'objet. Et par la suite, la partie qui est souvent un petit peu plus complexe pour l'élève, c'est la programmation. Par contre, lorsque l'algorithme est bien créé, l'élève comprend rapidement que la programmation qu'il a à faire, c'est tout simplement d'interpréter ce qui est destiné dans son algorithme. Alors, une fois que c'est déjà fait, je dirais que la programmation va évoluer quand même relativement facilement. Donc, le produit fini, je dirais, ça prend facilement 3 à 4 semaines, surtout dans les projets un peu plus complexes comme celui-là, parce que là, on a une carte Arduino Mega qui est à l'intérieur de ça parce qu'on contrôle 2 LED par joueur, on contrôle un bouton par joueur, plus les boutons pour la personne qui anime le jeu. Donc, à ce moment-là, ça nous prenait une Arduino Mega pour être capable de faire le produit fini. Mais à ce moment-là, les élèves, c'est sûr qu'ils doivent apprendre à souder, doivent apprendre à faire leur connexion électrique comme il faut et tout ça. Et sûr qu'en même temps, une chose dans le futur que j'aimerais bien faire avec eux, parce que oui, ça, c'est en 4e secondaire et souvent, les élèves arrivent en 4e secondaire et n'ont pas tant fait de programmation dans les années précédentes. Donc, ce que j'aimerais faire dans les prochaines années, c'est de simplement commencer à faire de la programmation, mais un peu plus tôt, peut-être en première secondaire. J'ai vu des beaux projets tout à l'heure qui pourraient être intéressants justement à faire avec des élèves dans les années précédentes. Donc, de commencer tranquillement de manière à ce qu'en quatrième secondaire, on puisse atteindre un niveau qui sera beaucoup plus évolué. Donc, d'année en année, j'ai déjà fabriqué avec les élèves des véhicules, comme on a vu tout à l'heure. Donc, tout dépend justement de l'année, de l'intérêt des jeunes et tout ça, et en même temps de la disponibilité du temps, surtout. Donc, le temps qui est disponible pour faire notre objet, puis aussi les matériaux qui sont disponibles. Donc, merci de m'avoir écouté.
Merci Christian, j'aurais bien aimé avoir étudié ça au secondaire, mais bon. Up next is the Dawson College crew presented by Professor Joel Trudeau. Joel, the floor is yours.
Thank you, Rima. I'm really pleased to be here with the Dawson College contingent for Arduino Day. So many interesting projects being presented here, and there's so much potential for innovation. So well done, problem solvers across the Arduino world. So I teach in the physics department at Dawson. I'm a founder and one of the coordinators of an initiative called SPACE, which is an acronym for Sciences Participating with Arts and Culture and Education. And it's now in its 13th year at Dawson, and it offers enriched learning and mentorship opportunities for students. And so as a learning community at Dawson, the general aim of SPACE is to empower and encourage students to integrate and apply skills and knowledge beyond the classroom, but also across the disciplines so they can develop deeper understanding, direct their own learning with passion, and share that learning with others. And this is supported by various venues and annual activities. Now, the mixture of STEM, STEAM, and maker education principles in particular help shape and guide what we're doing with students. And Arduino is an amazing platform for this, for exploring with rigor and imagination in ways that can be adapted to just about any level of education or background. And Arduino-based curriculum is being integrated at Dawson, and it will continue to be one of the technologies that we feature in projects, especially in our new Makerspace, which is super exciting. And of all the interesting things that I have the privilege of working on at Dawson, the student-initiated projects are by far my favorite. They're fun, inspiring, surprising, and challenging, and often have no formal grade attached to them, which is amazing because the intrinsic motivation to learn comes from the students themselves. So much is learned, and I feel I always learn more from students than they do from me. And just to briefly touch on the other project of relevance for the Arduino Day presentations, today's Momentum Labs. Now, Momentum Labs is an early stage startup project that will provide learning solutions for the fourth industrial revolution across high school, college, and early undergraduate education. So we're making custom virtual labs for use in curriculum, training, events like hackathons and special projects. So, but much of the core ideas have come as a result of living through the teaching and learning challenges of the pandemic. So as educators, the goal is to bring forward awesome technology for the next generation of interactive teaching and learning that is accessible to anyone, everyone, at any time. Arduino-based curriculum is a really important component of this goal. So a couple of my students, Kaylee Bates and Christo Sandev, and my collaborator, Tawfiq Jawar, are here as part of the Dawson College group. Kaylee will speak about her automated garden project that is connected to a contemporary issues space course that she's taking called Make Things That Matter, but also a personal project that she's passionate about. Hristo Sandev will speak about his experience as a winner of a mini coding challenge and a first exposure to Arduino with his teammates at the McGill Physics Hackathon that we took a group of space students to. Tawfiq will motivate and demo Momentum Labs interactive technologies for teaching and learning with Arduino, inspired in part by challenges faced working together at Dawson. I hope you get a sense of the potential of what can be learned through Arduino in their brief presentations, and invite anyone in the audience to connect with me if you'd like to learn more about what we're doing with STEM and STEAM education. So I'll pass it over to Kaylee to present the automated garden to start.
Thank you very much for that introduction. I'm just going to share my screen and I'll get started. All right. So today I'm going to be presenting, as Joel said, my automated garden. So first, I just want to talk about the benefits to urban farming. So it's super beneficial for our environment. As most of you probably know, it reduces transportation-related greenhouse emissions. It's efficient when you talk about how much space it takes up, and it also conserves water, especially when you use in cities. It reduces the amount of runoffs there are. It saves money, and it is a very, very fun activity. So basically, this is the very, very beginning stages of my project. It's the first prototype of my irrigation system for the project. So there's really two main components. There's the water pump that will pump the water and the moisture sensor. So to turn on the water pump, I'm using a transistor as a switch because I need to control it with a digital pin, but I also need around 3 volts of power to get it going. I'm also using a moisture sensor, but to convert the analog input into digital, I'm using a potentiometer to calibrate it to the soil's moisture or how moist I need it to be for the plant, and also calibrate it to the dry soil. All right, so I'm just going to go right into the demonstration. Sorry. So basically, this is the very beginning. It's not in its full state yet with all the pipes and stuff. So right now it's in the wet soil and it was outputting 0. And now when it's in the dry, it outputs 1 and the water pump starts going. But the problem is if it ever gets unplugged, it will just keep running the water. So how I fix that for now is just if it runs 3 times in a row, it will just stop completely until it senses moisture again, then it will restart the counting. So you'll see the warning message in just a little bit. Yeah, right here. It just tells you should check your soil correctly. Check your moisture sensor to make sure that it's in the soil. And then basically, yeah, you just put it, when you put it back, it just restarts the count. And then this is what it kind of looks like in the end. It's got the pipe connected to where you saw the water coming out of the pump before. And I'm using a drip irrigation system because it's really useful you can use it for seedlings or you can use it for fully mature plants, and it's just as effective. So again, this is the very, very beginning stages of my project. In the future, there's so much you can do with Arduino, and the more I've used Arduino, the more I realize that. And there's so much you can do. So in the future, I'd love to include NPK sensors to find out when you have to fertilize your soil, grow lights, photoresistors to monitor the light, humidifiers and humidity sensors to make sure the plant is in the right humidity and the right environment, and all of these will work together to just create the perfect environment for whatever plants you're growing. My goal is, there's a lot of automated gardens out there, and my goal is to make this a really cost-effective and simple design that anybody can build and anybody can use, and just encourage people to start gardening locally in communities, in their own houses, and just learn as much as they can about it, because it's really something that can make a difference. So thank you. Oh, actually, before I end, I just want to say thank you to Joel and Tawfiq for all of their help with this project, because without them, it wouldn't be here.
Thank you, Kaylee. Next, we have Hristo Sendev, who's going to present his hackathon Heat Rover.
Perfect. Thank you so much. So may I start by saying that I'm super impressed by all the other projects here that have been presented so far. They're just amazing. So anyways, hello everyone. So this is a project made by me, Joey Yu or Xiao Yu, and Sean Mayer. We are first year students at Dawson College in the Pure and Applied Enrich program. Sean is actually in the Enrich Health program, but they're both connected. We worked for 24 hours on this project during the McGill Physics Hackathon. So we had quite a short interval of time to solve all these problems by steps. So for the hackathon, the challenge was for us to create a heat rover using Arduino that would go around in a rectangular room, collect the heat data, and then plug that in as initial conditions for a heat flow simulation. So this was a big challenge for us because it was our first time coding with Arduino, and we had to make use of high school level math and knowledge of physics to come up with the algorithm and the heat flow model. At the time, we had been 2 months in, probably our first semester, so we had that much knowledge. So I'm gonna share screen. And I'm gonna showcase the video we used at the hackathon to present our project. So I'm gonna be explaining here what is happening. So this is a very nice 3D virtual Arduino environment offered by Joel and Tafik. So huge thanks to them. So since the hackathon was done online, obviously we could not attend in person. So that's how we had access to Arduino. So basically, this rover has 2 phases, which I'm gonna showcase the first 2 phases when I'm gonna be running the sandbox. But right now, what it's doing is that it is a sped up video of the rover running in a spiral-like fashion. So it starts at the bottom after the calibration phase. And then what it does is that it's gonna go in each corner of the room. And then after 4 turns, it's gonna increase the stopping distance. So it's gonna increase the required distance for it to stop. So ultrasonic sensor reads, let's say 10 instead of 5, stops, then it turns. So what this causes it to do is to make spirals that get smaller and smaller and smaller progressively. And during this entire time, we use multiple functions to calibrate and read the temperature readings gathered by the heat rover. And the coordinates also are being gathered by the ultrasonic sensors. So this is the heat map that is generated. And this is an unprocessed heat map. And later I will explain why these are points that are not at regular intervals, is because the virtual environment they made has this very non-negligible margin of error, just like in real life, where not every rotation or movement of the servos are 100% accurate. So we needed calibrating functions that will basically ensure our rover goes parallel to the wall. And this calibrating function will also return a Boolean that will indicate whether or not it was running parallel to the wall. And if it was true, if it was well calibrated, then our ultrasonic sensors and our readings would be taken into place, would be registered. Here we start the more software side. So here's where we increased the resolution. So we basically had per square, we gathered the average value that was registered, average value of heat that was registered in that parcel. And basically we plug that in our heat flow simulation. And just to go quickly over it, what we did is that we created our own function that basically looks at each neighboring parcel. And we basically had the rate of change vectors that were influenced not only by the instantaneous change of velocity, but we also had a force and vector model in which the instantaneous change to its neighbors actually applied force vectors. So there was also this acceleration effect of heat. Obviously, this model evolves quite nicely because all the heat is concentrated in the middle. But when we presented this, we also had other initial conditions such as like sinusoidal distributions of heat, which are pretty cool to look at. So this is the 3D visualization. Huge props to Joey and Sean for this, by the way. There was a lot of theory with Matplotlib involved, and it was insane. All right, so now it's for the exciting part. This is the virtual environment. Again, huge props to Joel and Tawfiq. Without them, it would be impossible. And this is our code. It's it looks bad, but it's not that bad. So obviously we can't show the Uno board, but it is pre-programmed. And here we have our trigger pins that correspond to the integer value of the the corresponding pin. And here we have multiple functions to measure temperature. Here we have a function to measure distance to the front, measure distance to the right, which is basically just the ultrasonic sensor readings. We rotate. We have a calibrating function that basically calculates the rate of change of each ultrasonic sensor reading. So of course, when that rate of change is 0, that means the rover is going parallel to the wall because it is constantly moving. And phase 1 is basically just the rover rotating on itself 180 degrees to accurately map out the dimensions of the rectangular room. So this is phase 2, where it's going to go in the corner of the it's going to go in the corner of the rectangular plate, and then it will start doing this logger. Well, it will start doing the spiral. So yeah. Yeah, so it was a really nice challenge, and again, it was our first time using our Arduino, and it was fun seeing our code actually work, even if it was a physical simulated environment. It kind of felt like a physical environment because it was just that accurate. It was just that immersing. So it was fun seeing our code for the first time not run on software. It actually impacts something in real life. And of course, this sparked a huge interest in our team to continue to pursue Arduino projects and to keep exploring new ideas, new technologies with Arduino. And hopefully one day we'll be able to make something that is actually extremely beneficial to the world, a bit more complex, a bit like a larger scale project, and maybe help out some people. That is our ultimate goal. But obviously, meanwhile, we love to solve these stimulating challenges. So yeah, thank you so much for listening.
Thank you, Risto. Next, we have Tawfiq Jauhar, who is going to talk about interactive technologies for teaching and learning.
Hello, everyone. Good morning. I'm just sharing my screen. So my name is Tawfiq, and I did my bachelor's in computer engineering at Concordia University. While studying during my bachelor's degree, I took multiple electronics courses, but I never got interested in electronics or electrical engineering. And it's mostly because of the way we learned the content in these courses. I could analyze and design a circuit by following formulas and rules, but I didn't really understand the concepts in a way they would stick with me after the course ends. Now, in 2019, I joined the Dawson team, assisting students in their active and experimental learning projects through the Space Initiative, and also introducing robotics and programming as a lab for the engineering physics course. And this was the first time I see how students get excited and engaged in activities that teaches them programming and electronics without the typical classroom approach. This was mostly possible because of the Arduino platform. Without Arduino, microcontrollers would definitely not be a platform for learning. Programming microcontrollers before Arduino is complex, and for every type of chip, there's a new learning curve. Like, just to give you an idea of what I mean by that from an engineering perspective, this is a basic program that I believe almost everyone who's starting with Arduino would start running it. It's basically the hello world of Arduino, and it is just blinking the built-in LED on the Arduino Uno board. Now, without the Arduino platform, what you're seeing here is the same program, but using the libraries for the chip of that is on the Uno board. And this requires a lot of skills in programming and in bitwise operations in C that will make it really difficult for anyone to actually start learning programming through this and even understand electronics, because it will require you to understand the ports on the chip and all the technical details of the chip that is on the board. And not to mention, if you actually get another board with another chip, you have to relearn everything, because it will have a different architecture and it will have all kinds of different things and libraries. Now, after joining the Dawson team, I started learning more about Arduino and electronics. I've even bought an Arduino kit. And because of my engineering education, it was easy for me to quickly understand and design projects using Arduino. But the more I got engaged with Arduino educational kits and resources, I realized there's a common thing that I see a lot. Learning of programming and electronics principles that make the platform so powerful is often just skipped over. Most kits are based on giving an instruction manual with code recipes already written for people. Often this results in a copy and paste approach to project building, or finding a cool project on Instructables and following the steps to get it running without knowing fundamentally how it works or how you might approach designing a similar project yourself from scratch. Now, depending on someone's goals, this approach can lead to interesting outcomes, but mastering basic skills and knowledge not only unleash the almost limitless potential of Arduino and the open source hardware, but also can enable you to teach others to do the same. And this is why at Momentum Labs, we started putting together a kit that we will be launching in the next couple of months. And we chose LEDs to be the main platform for learning how to program with Arduino and to learn electronics. LEDs are fun and interactive. And one thing we've noticed is that these LEDs are not usually found in beginner kits or curriculums, mainly because when you buy them, you have to solder the pins on the LED matrix or the panels. And beginners usually will not have the tools or the skills to do that. The kit will have three main LED components, which are the 8x8 matrix, the 16 LED ring, and the 8-bit strip. And all of the three main components will be soldered already. And of course, multiple other bunch of like electronics components, which will allow the curriculum to introduce all the components of Arduino, from digital pins to analog pins to PWM pins. And the kit will come with access to a complete curriculum designed for absolute beginners, where you would learn programming and electronics for the Arduino platform through creative and technical LED projects. We guide you through basic to intermediate concepts so that learners can design algorithmic patterns to light up the LEDs and build their own projects with the kit. Now, when the pandemic started, we had to find a way to continue the engineering physics labs at Dawson. And this is where we started building our virtual simulations. You've already seen our 3D robot environment, which is super cool. The feedback we've received from the students who didn't have proper labs during COVID was amazing. They basically loved it and they enjoyed the experience of learning. Our kit will have a full online curriculum for self-study for any learner, which is in development now. We are also developing resources for teachers to use our kit in classroom settings with an easy way to modify the curriculum as the teacher sees fit for a personalized learning experience. Now, to give you a quick like demo of some of our virtual simulations, which we've already seen the 3D robot. This is a workshop that we did for the McGill Physics Hackathon. The workshop started by introducing the components of Arduino, from digital pins to PWM pins to analog pins, and having a simulation of the temperature sensor, which basically led them to the 3D robot, in which it had the servos and the ultrasonic sensors and the temperature sensor. The second workshop was an introduction to our 2D robot environment, which we gamified it a little bit with coins that you need to collect to finish the challenges that you are seeing. And it led them to the 3D robot environment. Now, for our kit, we're also working on LED simulations. So this is basically an 8x8 matrix, and this is an Arduino sketch program here. And this is running in the browser, basically. It's a full simulation of the browser. And I have here an RGB, like an 8x8 matrix as well. And I have the same exact program that is uploaded to the Uno board. And I'm going to stop sharing so you can see it bigger. And this is basically the same exact program that we saw it on running on in the simulation. The only difference, I just reduced the brightness so that I don't blind your eyes, basically. But the idea here is that there's no compromise between the learning part of programming on the virtual world versus what you'll actually use on the real hardware. Now, if anyone is interested in following what we are doing and potentially getting their hands on our kit and beta testing with us, you can visit p4labs.io, and you can subscribe for any. Okay. Well, I'm not sure why it's not loading, but you can subscribe to get the latest news. Okay. So you can subscribe on our website to get the latest news for when we launch the kit and our virtual platform. Thank you, everyone. And it's great seeing everyone's projects today.
Thank you, Tawfiq. Our final presenter is Ivan Ruby from the Ruby Coders, currently doing his PhD in education.
So I think Ivan is having a bit of a Wi-Fi connectivity problem, and I don't see him in the list, so he might have been booted out. Maybe we can take a few questions or a few reactions from the crowd while we wait. Anna, did we have any questions in the live feed?
Nothing in there yet. Nope.
Was there any reaction from the presenters? I see the feed is full of great project. This is wonderful. Do you see any crossover? Are there any relationships to what Demetrius is doing with STEM teaching in Florida and what Christian is experiencing in Quebec City? And maybe with some of the challenges that Tawfiq is having with creating kits?
I think Genevieve is trying to talk.
Hi, I actually have a question for the last presenter concerning his online learning with P4 Labs. I just want to know, will it be available in French? Because I think some high schools may be very interested in what you're doing. However, I just saw it in English, but if it would be translated in French, I think it could be rolled out as a high school class, by the way.
Yeah, we are actually thinking of that from the first design phase. Like right now we are working on our platform and it's going to be multilingual. Basically, we're planning on launching French with English, and we're also seeing a lot of interest through our YouTube like videos for Spanish. We have a big audience for that. So we're aiming for that to be from day one to be a multilingual application.
Cool. And my second question is actually for Demetrius concerning his robot. I was actually very interested in the actual controller that you're using. What type of controller is that?
This is a VEX proprietary controller that comes with it. And so you can see that there's the Bluetooth dongle here that connects directly to the processor.
Okay.
So it originally started as just a VEX project, but then it just has kind of grown beyond the proprietary stuff to including the Arduino Uno. Because
I'm sorry, it looks like a P4 or an Xbox controller. So I want to know, did you hack a controller and add an RF chip?
No, you do have to program each of the buttons. You know, program all of these buttons for the functions that you saw, but this comes with the VEX kit, or this is just part of like their different materials that they have. But the cool thing about this that does have I/O ports, so I'll be able to communicate with an Arduino Uno when I program the buttons as well.
Just to let you know, you look like a big kid having fun in his with his toys. It's awesome.
Thank you.
So I believe that Ivan has managed to log back in, I will let him present. I believe he has a bit of a shaky connection, so if ever there are issues, I can fill in for him in terms of what the Ruby coders are. Over to you, Ivan.
Hi everyone, and thanks for the patience. And I'm sorry again for my shaky internet connection. I just ran to get another Wi-Fi connection. So yes. It's been an interesting day. But I'm here today to talk about something that we started doing. And yes, and we had a lot of interesting conversations and interesting presentations. And one of the things that we spoke about was how we were trying to address the challenge that was posed to us by the pandemic. As a maker jams, where people involving electronics, robotics, 3D printing would meet and just have an. So with the
So, Ivan, we're having a hard time understanding the flow of your speech. I think there's a major lag on your end. One of the things that I believe we can talk about is the Ruby coders. So the intervention that Ivan has created is a group called the Ruby coders who meet weekly or bi-weekly, depending on the season. He created an interface where he leaves some props and some starters for conversations around coding. And the purpose around the Ruby coders is not to just get into the kit and start hacking the kit right away and taking a ready-made Arduino code. Basically, they're called sketches. So you take a sketch and you upload it, and then all of a sudden your robot works, or all of a sudden your widget works. What Ivan tries to do with the group is he brings people through thinking about how computers think. So how to think like a programmer so that you can get a computer to do something. I know that some people attended the Ruby coders in the audience, and I think Geneviève actually was one of the participants in the Ruby coders. So maybe Geneviève, do you remember, or can you narrate what happens in a typical Ruby coders event? And I will ask for the website so I can show this after.
Absolutely. Like I said, I was very intimidated by the whole Arduino thing. I think I was more intimidated with the programmation of it all and how to put everything together. I joined Ruby's Quarters back in December, actually, and we did an online class, and he had ivanruby.github, if I recall correctly, and everything was clearly indicated, a very nice step-by-step guide. And what he did with me personally, he never told me what I had to do. It was more of a discovery of the platform, a discovery of how things work. And even though I made mistakes, of course, he never gave me the answer. He always directed me of where I could find the answer. So he was more helping me troubleshoot the project for myself, which really helped me when I took that knowledge and I applied it to my own project. I didn't feel I always needed somebody to go to. I was able to figure things out on my own, which is what his class gave me a lot of what I call self-confidence in figuring things out and in tinkering, and to not be afraid of making mistakes, because half of the time, even professionals, what do? Mistakes. So yeah, and I really liked how he just really, it was more of a self-discovery learning type but he always directed it, and he was always there to help me when I was making a mistake. It's like, oh, well, maybe you should look here. And that's where I did, and I solved my problem. So I greatly enjoyed, I only had the opportunity to do one class, but it was all about LEDs, and I got my programmation to work. I got my Tinkercad plugins to work, and I took that knowledge and I built that.
Awesome.
So I had the confidence of doing something on my own. And like I said, it's so open that now I have, oh, but I can do this and I could do that. So that's what it really gave to me.
Thank you, Genevieve. I think Ivan's connection is a little bit better. So Ivan, I will let you jump right into the core of your presentation if you can.
Yes.
Share your screen.
Yes. Thank you very much, Genevieve. Thank you for your kind words. And we are definitely going to get back some point in the summer. So if you can see my screen, I'm just going to show you the online resource that Genevieve was referring to. So the group is called Ruby Coders, and we have a website where I tried organizing and structuring the information that we use to go about our activities. So there is some different pages. One is the presentation. We speak about what we do, what is necessary, or what are the requirements. Essentially, it's just willingness to learn and curiosity, and also an internet connection in case we are going to meet online. Keep in mind that all these activities can also be done offline. And some of the things that Genevieve was talking about in terms of the approach is essentially what I tried describing here in terms of we prioritize learning together and from each other over being taught. So that's the part where I try not to teach, but I try to create an environment where people learn from each other. So exploring and developing an understanding over memorizing and experiencing problems as learning opportunities. And this is really key because we definitely try not to avoid problems, but we try to have a structured approach to approach them or to solve them. So there are also some quick guides that I developed just to bring some basics and fundamentals to the learners. And keep in mind, this is a free and publicly available resource. So going through the actual activity, there is a tutorial so that you can experience what it looks like. And going through the actual activity, the approach that I used uses Tinkercad as an online platform for circuit simulation. So again, you can also have a free license or a free access to it. And I'm trying to switch. Okay, I was just trying to open. Okay, so the way we structure the activity is by dividing a project into 3 or more conceptual parts. What just so happens is that in robotics, we have a lot of things combined. We have the programming, we have the wiring, we have the figuring out how the physical is connected to the virtual. So essentially, I tried replicating these as phases. So in one phase, it's just wiring. So your task is only to wire elements together. So this way you can have challenges that are only related to wiring. As an example, there might be a missing component, there might be a wrong component added to it. And these are all things, these are all events that take place in a real world as well. So this will be one type of the challenges. And then I'm just going to go briefly through the part that most matters in terms of how the project ends or how you have a complete solution. As Genevieve and I believe many other participants were mentioning earlier on, we try to focus on planning as a key aspect of programming. Most of the things that you see here, and I know it might look busy in terms of the screen because we have a lot of orange annotations, and these are called comments. They're not executed by the Arduino or by your computer, but we try to tap into comments as a way to bring to create a window so that people can describe what they want to do before they do it. In a way, we try to focus on solving the problem before we create the program. And as you can see here, we have a description of the steps, and each step represents an action or an instruction. So the only task left after you create your blueprint or you create your list of steps, and this is what you call your algorithm. The only step left is just substituting each equivalent step or each step by its equivalent programming instruction. So it has been a really interesting challenge. It has really been an interesting opportunity to learn from people, to see a lot of people developing and exceeding. It's definitely an ongoing project. The next step with this will be to create learning resources for educators so that they can create their own challenges. If we look at the page here, there are about 5 activities that are created. Each of them consists of a prompt, initial project state, and then you have 1, 2, 3 conceptual phases. So you have the wiring phase, which is one Tinkercad project, calibration phase, which is another project, and so on. So I'm trying to modularize how these activities are created and then share this information so that you can create your own challenges, you can create your own activities. So thank you very much for everyone for their patience. Thank you very much, Genevieve, for your kind words. And I'm sorry for my internet connection issues. Thank you.
Thank you very much, Ivan. This is amazing. An hour and a half of splash talks around the world, around the domain of Arduino. That's wonderful. There's a question actually that came in from Facebook, which is, what does Arduino mean? It's the name of a company. So if you look at arduino.com, arduino.org, you will find the open source company that was created by Massimo Banzi and David Quartiellas. So if you want to learn about Arduino projects and if you want to learn how to code, we have 2 options for you. The Ruby Coders meet and the way to contact us is through either makercultures.com or actually let me rewind this. Makercultures@gmail.com. There's also Education Makers, where we have all our contacts. The website is www.educationmakers.ca, or you can contact us on Twitter very easily with the handle Education Makers. There's also Momentum Labs, which we have pasted in the chat and also on the Facebook stream. And there's all sorts of ways in which you can contact us. We have very active groups. You will not receive particular lessons. There's not a particular course, but there's a community of people who get together and they like to tinker around Arduino projects, around coding. Not everybody's an expert. We're usually scratching our heads and we're trying to figure out the code. We have some expert programmers such as Tufi and Ivan and Demetrius, who are very, very skilled at this. But at the same time, there's a lot of other people who can help out and help build your creative confidence and not be intimidated, because coding is our future. Coding is life in the 4th Industrial Revolution, and coding is the language of machines. So Tufi just pasted the link for p4labs.io. I'm going to make sure that all of this information is available also on the Facebook stream so that you can all have access to this. So other than this, I think this brings us to the end. Is there any, maybe we have 1 minute for a question or a comment? I haven't seen anything else come up. Wonderful. Thank you very much, Rima, for organizing all the talks and managing everything with the participants. Your contribution was priceless and very, very appreciated. And thank you to all the participants as well. For presenting your projects in such a concise way. It's always great to see the variety and to see the dynamic presentations get presented one by one after such a, inside such a quick event. So over to you, Anna, so that we can finish this event.
Awesome. And thank you, Anne-Louise and Nadia Bouyan, who's here as well, for your introductory comments and for being here organizing this. Thanks to Media Institute and the Innovation Lab, Dawson College as well, all of the participants in your amazing projects. It was so wonderful to witness and be a part of this. And of course, I'll just remind folks that we'll actually follow up with an email for everyone who registered, and we can include all of those links in there as well. So you'll have the info on Facebook and by email as well. And I've already put a link in the chat to the recording. So on that note, now that we're all inspired, it's a great way to start the weekend. to the audience for sharing your time with us and for participating in the chat and giving some love to the makers here today. We really appreciate your participation. We're going to close up the webinar now. So I wave goodbye to you and wish you a wonderful rest of your day. Thanks again. Bye.
Thank you, everyone. Wonderful presentations. Congratulations. And go have a wonderful Saturday morning.
Coffee break. Enjoy, everybody.
Bye.
Bye, everyone. Thank you.